kupata kompyuta.
I hope it will show up.
All right, hello everyone. This is Dr. Elahe from the School of Information Technology. Welcome to IT 432 Systems Analysis and Design graduate level. I'm very excited to be here with you. And usually I have a full lecture on the first day of my classes. This is a graduate level course. During the first 2 weeks, I'm going to be doing a little bit of overview and review of things that I would expect you to know already. That would help me understand what are the areas that we may need to revisit or focus on a little more. So if you've done, hello? If you've done courses with me before or courses in the department, some of the ideas may look familiar to you. And some of the ideas may be new, even if you've done the courses here at the School of IT. So don't be alarmed or don't feel like I expect you to know things that you don't know. If there is an area that we need to revisit, we will revisit. The course is very hands-on, so we'll do our first lab exercise on Wednesday. We'll ask you to participate. Sometimes if I don't hear someone volunteer to answer a question or share their opinion on a discussion or do the work, I will call you by your names. There is a little bit of information on RegiNet. I have a start here module for you. I asked you to work on a mini assignment, do your introduction video, read the syllabus and do the syllabus quiz. So please work on those. I don't spend class time to review the syllabus. You're expected to read that and do the quiz, and that is enough for me to know that you know the structure of the course and the requirements of it. Any questions from the class before I get started? No? Just so you're aware, I'll be asking a series of questions. So I'll give you a few minutes or 1 minute or 30 seconds for you to think about, maybe remember what you've learned before and share your reaction. So be prepared, be present on your desk. I know all of you have chosen to show up as a black box. That's okay, I'm getting used to this. But gets good, Anitha. It's great to see your face. Daniel, too. Good to know you are sitting at your desk. Shivani, that's great. It's great. So, and Pranav, Kelvin. It's great. I'm used to black boxes, but in my previous class that I just finished, there were a few cameras on. It felt so good. Great. So you have cameras, you're just too shy. All right, perfect. So be prepared to answer the questions that I ask. I'm gonna go over things that I feel like you should know, but if you don't know, we're gonna stay on them longer. So don't feel shy to ask for us to explain things and review at a deeper level. Some of you have been out there in the job market years after your education, so it may take us a little bit to gauge your readiness for what we're gonna do together in the class. So let's see what I have here. And I'm gonna go to the presentation mode, make this one small, and share. All right, Anissa, I need you to confirm that you see the full screen version of my slides. Do you see that?
Yeah.
Yes, Dr. Eli, I can see that.
Perfect, the full screen, not the two parts. No?
No, there's a full screen.
Okay, perfect. So welcome again to Spring 2021. Nobody thought we're gonna be doing it like this, but we're doing it. So we might as well stay positive and use technology to help us replicate some of the experiences that we could have in a face-to-face setting. I'm going to talk about project lifecycle phases and SDLC. I'm going to talk briefly about project classic mistakes. I'm going to talk about stakeholders and requirements and some of the diagrams that you have created in the courses before this one. The first lab exercise is on Wednesday, and I'm going to give you a simple problem, and I'm going to ask you to create a few diagrams to show some of the things we need to do in terms of discovery. Oh, let me ask you, some of you have seen this before. What is the rate of success in IT projects? If you have seen the numbers before, don't share them. Is it more than 50% or less than 50%? Less, Daniel?
More than
Less.
50%.
Yes, do you think it's less than 50%?
For on time, less for on time. Yeah, I think it's less.
What do you think, Kavisa?
You mean the success of a project, is it?
Yeah, like as a profession, what's the rate of success for IT projects?
I feel it's more than 50%.
It's not. So the numbers I have on the screen are a little bit old, but have been stayed more or less the same, about 30% successful, about 50% challenged, and the rest are failed. So this is a little bit of historical information telling you that we're not improving a lot. So the profession is suffering. And one of the reasons is that there is work to be done in terms of system analysis and design, making sure the requirements are elicited properly and are transferred to requirements and design specification properly. So there is some role that you as a business analyst can play to help with these numbers. Now, the question I have for you, what's the difference between a challenge project and a failed project? What are the dimensions that we are defining failure, success, or challenge based upon?
Well, challenge is probably not on time or incomplete. It just didn't have all the features that the stakeholders wanted.
So
And
Daniel,
then failed was just wasn't there. It didn't make it.
so Daniel is mentioning two dimensions. So first is time, yes, wasn't done on time, didn't deliver on time. Second is scope. This scope, the list of functionalities that was delivered was far from the list that was promised will be delivered. Any other part of the project could lead to challenge or failure. So two dimensions from Daniel. I need a third one or a fourth one.
Would it be cost? Maybe it costs too much to
Exactly. So Matthew talked about costs, time, and scope from Daniel. Anybody can think about another one?
Ma'am, label, like how many people can work on this? We have limited resources to work on that particular thing, and we need more resources to work on the technology so that we can achieve our goals.
Perfect. So your the human resources and what you spend on them, it will impact your time
Yeah.
and cost. So the what you gave me is triple constraint. What we call this triangle is triple constraint: time, cost, and scope. They are interrelated. So if you want to finish a project earlier, it means that you may need more money, yes, or you may have to shrink the scope, the list of features that you're delivering. Now, the quality also stands in the middle, and it will be impacted by these three dimensions. So if you have to finish early and you cannot get more money, or you cannot shrink the scope, you know that the quality will suffer. This is a very important piece that we keep in mind in our projects. Triple constraint: time, scope, and cost are interrelated, and they all impact the quality. So let's see what we have. Do you think a traditional project is better, or an agile approach to project is more useful? Some of you in your undergrad versions of this course have seen waterfall, yes, have seen spiral model. What are those models? When do we go by waterfall?
It's one after the other. I mean, like first you do the design analysis, I mean requirement gathering, and then the design analysis, and then coding. I mean, waterfall model is nothing runs in parallel, one after the other. Yeah.
Exactly. That's a very good description,
And
Kavisa.
I'm sorry. And when the requirements are not changing frequently, then also we'll go to the
Perfect.
waterfall model.
Really good input there. So first one, things happen sequentially, one after the other. That's the definition of waterfall. And usually they make it very costly for you to go back. So if you're done with design, you're in development phase, you want to go back, you have to file paperwork, and it's going to be hard to modify your design after it's over. Anissa is giving us a reason why do we choose waterfall in some organizational settings or for some projects, because the requirements are well known and the organization values the structure over flexibility. So in government institutions, in military, in some projects that have been done over and over again, you may choose to go by waterfall or a variation of it. So maybe you remember hearing about modified waterfall, when you allow phases to overlap. They still happen sequentially, but they can have overlap. All right, what do we have for an example of agile approach to SDLC? That's the picture on bottom right. What is that?
The same phases would run in parallel, and we would not wait for the previous one to finish as such. I mean, they.
So what do we see here? We see a little bit of planning. That's the core. So at the beginning of the project, you do some planning for the whole project. Not all the planning, some planning. And then you go through iterations. And during each iteration, you do a little bit of planning for the iteration, a little bit of analysis, a little bit of design, implementation, deployment, testing. So it seems that all phases of SDLC, they happen in a single iteration and you produce a prototype. In some cases, you deploy them. In some cases, you don't, depending on the approach. But you produce a piece of working software at the end of each iteration. And then it goes on until the product is complete. Now, what is an advantage of what we call an agile approach to SDLC, and in this case, spiral model. What's an advantage? Let me ask let me ask Kelvin.
Okay.
Kelvin, why are you upside down?
Yes, Dr. Javadi, I do not have an IT background, but I'm sure with time I will catch up.
Yeah, absolutely.
I am from a background of statistics.
That's good. That's great. That's a very strong background. Yeah, I'm sure you will be able to catch up. But just from hearing a brief description of a spiral, the project is going to be completed in iterations. During each iteration, you do a little bit of analysis, design, coding, testing, and implementation and deployment. What do you think is a positive aspect of this approach?
A positive approach of the agile method as opposed to the waterfall could be the flexibility.
Exactly.
It's
What's a
quite
disadvantage?
flexible.
Perfect. I'm going to go to Pranav. What's a disadvantage?
It's too time consuming.
Can you elaborate more on that?
Okay, so the process of the fast process where we try to take and understand the defects of it and try to modify it takes more duration of time than following a system where we regularly adjust and make moderations to this type of model.
So there is a lot of, so you are creating prototypes, and the purpose is to use that to involve stakeholders and get their feedback. And by doing that, you're exposing yourself to more ideas and more changes. That's correct. So they usually say that it's better for an expert project manager to make the transition from traditional to agile. The gatekeeping part of a work that a project manager should do, meaning that making sure the scope is not expanded, becomes even more critical in a spiral model or in general in agile approaches. Why? Because again, you are asking users for feedback, you're involving them, and you should be able to know when you're done. And sometimes that's hard to know, and you may be cut in iterations forever. So definition of done, they say, it's very hard when you take an agile approach to SDLC. When am I going to be done? And having a strong project manager role could help with that. If there is no project manager, then it's going to be upon you as BSA, Business System Analyst, or System Analyst to make sure the scope is not increasingly expanding. So when we talk about project size and method, some of you may think that, okay, and a more structured project, I will take a more structured approach like waterfall. A more unknown project, a project that's new, it has maybe R&D components to it, it's a cutting edge project, or a project with a company I don't know, on an area I don't know, with people I don't know, maybe an agile approach would be more useful. So sometimes it helps to take agile over traditional. And what I want you to do here, spend 2 minutes on this chart that I'm giving you. So it looks at the success rate, challenge rate, and failure rate for projects based on their sizes and based on their approaches, okay? You're gonna spend 2 minutes and you're gonna give me a statement. For example, you're gonna tell me, look at the box that I highlighted. You're gonna tell me that for Large projects, the rate of challenge, the challenge is there, and it doesn't change a lot from from agile to traditional. See, large projects, just by the sheer volume of the people involved, of the line of codes you're writing, of the geographical coverage of the project, they're going to be challenging. And it doesn't help much if you pick traditional or agile. It will be still challenging. But I'm going to ask you to look at the numbers, look at the success rate for the small versus medium versus large project. You look at the approaches and give me one understanding that you can get from this picture. So 2 minutes, and then I'll ask a few of you to share your statement. Eric?
Hi, Professor.
Hello, go ahead.
Okay, so and this is new to me. I don't have a background in this, but I've come up with something. So for a small size projects, failure is there. One can fail, but the rate of change of failure choosing the agile method to the traditional method is 7%. That means the rate of failure for the traditional method is higher than that of the agile method by 7%.
Perfect. So you look at the small size project, you look at the success challenge and failure rate, and you observe that in general, agile projects are doing better. So let's go to Jonathan. What did you observe?
I observed basically the same thing, that agile in every size project is the success rate is higher than the traditional model.
So now that you both of you have observed this based on a methodology and success, so you're staying on these columns. Success rate in general is much more for agile when compared to traditional or waterfall. Can you tell me where, in what size project, that difference is more salient? So like, is it for large projects that the difference is more salient, or the percentage of difference, or for medium size or small?
I would say medium-sized projects.
So for medium is threefold difference. For large is 9-fold. And for small is less. So there is another picture that I'm going to show you at some point, that some in small projects it's much easier. So perhaps the difference is not too much to change your approach. Like if you have a team and they are all used to waterfall, the gain is not that much to justify retraining and transitioning to a new approach. For larger projects and medium-sized projects, the gain is just like it justifies the work you want to put in retraining your team. So good observation by Jonathan and Eric. Let's see who hasn't talked yet. Manasa, are you here? I don't see the full list, but
Yes.
go ahead. What did you observe?
Yeah, I observed almost the same thing. But both the agile and waterfall models have the challenged one, like me, success rates little higher compared to other. And
Exactly.
for all the other methods, the traditional is having a less success rate when compared to agile one.
Perfect. So the challenge, there is a difference in success rate. Challenge rate is more or less the same. There is not a huge difference. Or Eric or Kelvin with a statistic background, maybe the difference is not statistically significant. Any other observations? I'm going to get one volunteer, hoping that those of you who haven't talked yet. Anybody wants to talk? Let's see. Queen, go ahead.
It's Anita. So what I observed is, even though the agile and waterfall model, they are the agile is more successful than the traditional model. The challenge rates, it seems there is not much difference. Still almost the same, and both are facing the challenges.
Exactly. That's middle column, more or less the same. And then you look at the failure. Which one is showing the big difference? Let's go to Quingy. Are you here? And help me read your name correctly. Let's see if I Quing. Yi. Hi. Hello. Can you tell me your name?
Qin
Yi. Okay, go ahead. What did you observe?
I think like with a project size become larger, and maybe because more people take part in the same project, and it's more easy to meet the challenge and failed.
Oh, perfect. So you're comparing project based on their sizes. So just by increasing the size, you decrease the success rate and you increase the failure rate. That's a good observation too. Thanks, everyone. Just make sure everyone, when I ask you a question, everybody is the party object to being the discussion partner. So here, what is this one? What is this chart showing? You may have seen it before, you may have not seen it before, and this is for me to know what you know and who knows what.
I'm thinking it's a project life cycle, starting from where the project starts and where up to the phase where it ends at the
Perfect. Perfect. This is project life cycle and it's 5 phases. It shows the amount of resources and efforts required for each of the phases. You start with defining the project, you go to planning, you have the execution in the middle, and that's when you actually create an information system product, or update an already existing information, upgrade an already existing information system product. Then you close and you evaluate. One thing to pay attention here, that closing and evaluation take almost the same amount of resources and effort as defining and planning the project. And one of the reasons the IT profession as a whole is not improving a lot in terms of IT project success rate is that we don't spend enough time on that last phase, on the evaluation phase. That's when we and our team members and our stakeholders need to spend the time to analyze the project, find the best practices, find the areas of improvement, and find the areas that we failed in. So evaluating the project, why is it tricky to spend time on? Because we're tired of the project already. We don't want to spend another day thinking about something that we've been working on for months. We don't like to do it, and there is nothing we can do unless we put a requirement on ourselves. It's specific standards and documentation to be produced out of that phase. Now, as you have seen SDLC phases, Lance, it's now your turn. Go ahead, unmute yourself, Lance.
Hello.
Hello. SDLC phases, systems development lifecycle phases. Do you remember what they were? Just name a few.
Like the analysis.
Yes.
Design.
Yes.
Crap, I don't remember all of them. Implementation.
Perfect. You gave me a good list. This is the list. There is a problem identification, planning. Those are also related to project management activities. You have analysis, you have design, you have build, test, implementation, and deployment. Those are the main processes for SDLC, but they don't always have to happen at the same order that you see on the screen. Depending on the approach you're taking to SDLC, you may do some of them earlier than the others. For example, if you're doing test-driven development, you will write test cases before you write your code. So SDLC, System Development Lifecycle, phases, when do they kick in during PLC? I want you to connect these two ideas that you've been hearing about, or maybe it's the first time you're hearing. Eric, go ahead, it's your turn. How do they connect?
Professor?
Yes?
I think this is the first time I'm seeing these things.
This is the first time?
Yes, please. I have a background in statistics and actuarial science.
Good. That's a good background. So you're going to be a great fit for being a data science professional. So let me talk about the middle phase in SDLC. That's executing the project. And that's when you actually create an information system product or service. So that's when your SDLC kicks in.
Okay.
So analysis, design, implementation, testing, and deployment in one way or the other will happen during the middle phase of PLC. Now you may ask, Professor, how do I plan for a project I haven't done analysis of? Yep, that's true. You may do part of analysis and discovery during the first phase. You may do a little bit of discovery when you plan the project, but the bulk of work will happen in the middle phase after the project has been approved. So analysis discovery in some way happens earlier because you have to know a little bit about the project before you plan or propose a business case around it. People have done studies of the projects. There is a case study that's called Infamous Failures classic mistakes and best practices. They did post-mortem reviews of 99 projects in 74 organizations. These are 10 most heavily cited failed projects. They include Nike, Hershey, Bank of America, and a lot of other big names that you have been hearing in the business. What they did, they did the post-mortem when you look at the project after they died, and they realized that if they analyzed them and they came up with a list of what they call classic mistakes. And those are the mistakes that have been occurred again and again in our profession. So they say failure teaches more than success. And if we do believe the frequently quoted statistics that 2 out of 3 IT projects fail, that's the number we just saw earlier. The rate of success was 30%. Then IT profession must be developing an army of brilliant project managers. And we told you there are many reasons we're not learning, and one of them is that we don't spend enough time on evaluation. So there is some sort of insanity going on in the world of IT projects. They did categorize the classic mistakes, those mistakes that were happening again and again, into 4 classes: people related, product related, process related, and technology related. Which one of these categories do you think had the highest percentage of classic mistakes? Or let me ask you this way: the most frequently committed mistakes, okay? Do you think they were related to people, processes, technology, or product? Let's ask who hasn't talked it. Aisha.
Hi, Dr. Javadi.
Hello.
I think the 4 processes are totally dependent, and I think all the 4 processes have like they're interconnected, and
So they came up with these mistakes that were happening again and again. Okay,
yeah.
They came up with a list. I want you to guess. Do you think those mistakes were mostly related to people, processes, product, or technology?
I think it might be people.
Exactly. Good guess. People and processes were top, more than 40% each of them. And I think it's about a single digit percentage for technology and products. So for some of us, when you go to the workplace, you think, I know the technology, I'm going to be successful. But no, there are people you're going to be dealing with, and there are processes that should be in place to assure your technology skills go to the places that they can take you. So let's watch a video together, and I want you to tell me if the project was successful, was going to be successful, or failed, or challenged. Okay, this is a short video. Let's watch it together and see what we can get from it. Let me escape my presentation mode. Okay, find the video, and I would need one of you to stay unmuted to confirm that you can actually hear the video, okay? So Daniel, maybe you do that. Tell me if you didn't hear the sound. Let me share first, and then I'll ask you. Where is my share button? I lost my share button. I found it. This is that. And I think I have to change the sound system to system.
Have met that objective and then some.
Yeah.
You hear it?
Yes, yes.
Perfect. I'm going to remove the names.
The Bradley Armored Personnel Carrier will bring troops to a combat zone swiftly efficiently and safely. It will hold 11 men, plus a driver, and features a 20-millimeter cannon, which will provide ample firepower and at the same time flexibility. Lightly armored, speedy, and solidly engineered, our troops will be arriving at the battlefield in the very finest American technology has to offer. And at $1.5 million per, a real bargain.
Nice work, Colonel.
Outstanding.
Damn impressive.
In other words, it was designed to be a big taxi cab, drive guys to the battlefield and go back home.
But how did it end up with a turret on top?
Well, this is all well and good, Colonel Smith, but...
Something wrong, General?
Well, with this gorilla in production, I don't suppose there's going to be anything left in the budget for my scout.
Down it, Bob. You don't need scouts. You have radar, air recon, satellites.
You always need a scout. And you know what I'm thinking? Why couldn't this thing serve as a scout?
But it's a troop carrier, General.
But this is a speedy vehicle. Why can't it be both?
Well, for one thing, it's too big. And for the other, you can't really see out all that much from inside.
Sounds like a design flaw to me.
Design flaw? No.
We'll just stick a turret on top with lots of opticals.
But then, sir, it'll be even bigger.
Well, what's your problem, Smith? Not elegant enough for you?
Well, the thing is, General, it's kind of hard to do a sneak and peek when you're over 10 feet tall.
He's got a point, Bob.
Well, all I know is we need a scout. This is fast enough to do the job, and it's funded.
Well, actually, we're a hair over budget.
You turned the Bradley into a scout. We're going to be selling them off to some El Presidente de Chimichanga in no time.
Anything for surveillance ends up south of the border before the paint even dries.
When you needed that anti-aircraft gun, who backed you up on that?
You did, Bob.
And who testified to appropriations on behalf of that gun?
You did, Bob.
I'm talking to appropriations next week. Now, do I sell you on my scout or do I not?
You did, Bob. And how about some portholes along the side for individual firearms so the fellas can stick out their guns and shoot people?
Good. And you know what, Colonel? We already have the turret. We ought to get the biggest bang we can up there.
I'm sorry, bang, sir?
You can't hurt anybody with that pansy-ass gun. Add on some firepower.
Where am I supposed to fit the extra ammo?
I don't know. Can't you just shift things around? Make some room.
You already got 4,400 rounds of machine gun ammo. Now you want to add 25-millimeter shells.
General wants his ammo.
You can't have his ammo unless he runs alongside this thing carrying it.
Well, can you just squeeze it in?
No.
Oh, come on, just squeeze it in.
We're not trying on Levi's here, Colonel.
Are you telling me that in a vehicle this size, you can't find room for a few rounds of ammunition?
Not in its current configuration, no, sir.
So the configuration's wrong.
There must be something you can dump.
Dump, sir?
Something you don't need.
General, the interior is very spare. Besides the ammunition and the men...
Maybe you can leave one of the fellows behind. Let the ammo where the men go.
Sir, it is a troop carrier.
So, make a couple extra trips. What's the difference?
They want a transport that doesn't carry men and a scout that's got a cannon as big as a tank's on it.
And portholes.
Oh, great, portholes. So the guys can shoot out whatever they can't hit with their cannon.
You don't have to buy the damn thing, Jones. Just draw it. That's one hell of a cannon.
That's a problem.
Why?
You go out in a battlefield with this pecker sticking out of your turret, and the enemy's going to unload on you with all they got. Might as well paint a big red bullseye on the side.
But it's a troop carrier, not a tank.
Do you want me to put a sign in it in 50 languages? I'm a troop carrier, not a tank. Please don't shoot at me.
This was going to be so beautiful.
That's good work, Smith. Looks perfect to me.
Thank you, sir.
Thing is,
Yes, General?
looks a little like a tank with that cannon on top. Probably gonna draw more fire.
Actually, sir, that has come to our attention.
We know it's not a tank, but will the other side?
I guess we could always thicken the armor, toughen up the hide a bit.
Colonel Smith, could you explain why you put those portholes there?
Yes, sir. As per your request, so the men could shoot out at the enemy.
You're joking, aren't you?
Besides, portholes? What are we in now, the Navy? Say, you think you could make this thing amphibious? You know, get the troops across a river?
No. No, sir. No. No.
Amphibious? The Bradley's supposed to swim? In theory, at least. Amphibious troop carrier / scout / tank. Couple more months, I bet they can get this thing to fly. What's this in the margin? Please help me. I am losing my mind. RLS. Lieutenant Colonel Robert Laurel Smith, Head of Oversight and Development.
All right, class, what was going on here, you think? This is one of the classic mistakes. I want you to tell me what the classic mistake is.
Their design keeps
requirement-
changing. Sorry.
Sorry, go on. Sorry.
I was going to say that their design keeps changing, so the scope is always being redefined every time they keep making up new designs.
You're muted, Professor.
Exactly. Correct. The scope was changing. Shivani, what was your idea?
So, ma'am, professor, in this video, you person was changing his requirements on every point, and it was very difficult for the developer to develop something in which the requirements are not clear.
Exactly. Moving target. The requirements are always changing. There is a real story that goes along with this movie. That's an amphibious project. It was in the military. It took them 11 years to finalize requirements. 11 years. And I want you to guess, what do you think the project is going to be successful, challenged, or a failure?
Challenged.
Actually, you could say this was challenged at the beginning, but eventually the project was terminated. So that's a good place for us to discuss what's the difference between a challenged and a failed project. A challenge project is one, as you described, could be over time, over budget, or not delivering the scope, or the quality will be suffering, but still is kept alive. So the project lives to the finish line. The sponsors will still pour money into the project. Why? Sometimes there are regulation reasons. It's just do or die. If they don't do it, they can't survive. Sometimes it's the same reason, but for competition reasons. So like Hershey, they have to sell more candy, or otherwise they can keep up with their competition. So sometimes this happens in government institutions. They keep a challenge project alive. Why? Because the government institutions are financially conservative, and they are prone to sunk cost fallacy. They say we will spend some money on this project, so we don't want to lose the money that's been spent on the project. So they keep spending more. And so many examples of these projects you can Google online, or you can look at the case study that I just shared with you. The list of classic mistakes, one of them is a scope creep that you saw in this video, and that's number 14 on the list. What do you think could be a classic mistake? Something that you think it happens so often in the project. I want you to guess before I show you the list. Classic mistakes, they happen too often. Scope creep that you just saw in the video is one of them. Any other mistakes do you think could happen in projects over and over again based on your
estimation?
Oh, wow, that's on top of the list. Good, and that's a process-related mistake. Scope creep is also people and process-related. Estimation.
And there is no specific plan for that. And if the requirements are keep on changing, so I think there is no specific plan or design.
So it's poor planning. That's number 4 on the list. Good. Give me one more before I show you the list. Daniel, you want to share one more?
I was going to say poor planning. Another maybe low expertise, like the people just inadequate expertise.
That's down on the list, but it's on the list. Let me see. Lack of skilled workers is somewhere. I'll let you find it in a minute. Give me one more, Parnavi.
I think there was there's no coordination among the people who are working on that project.
So coordination and planning related. So let's look at the list. So I'm gonna keep this list in front of you and tell me if you have any questions or anything feels like it's surprising for you. That's a classic mistake. Poor estimation, first on the list. Stakeholders management, planning, future. Scope creep is number 14. So many things happen at a higher percentage. Skilled workers are somewhere here.
Would you be able to elaborate on number 7?
Number 7, insufficient project sponsorship. This one?
Yep.
Just money is not coming in. So usually you want someone to champion your project. In a big organization, you are usually competing with other project managers for the same sources of money. So if your head, like the project manager or somebody who is championing your project, is not doing enough work for you, you will have problems securing money. So visual thinking, you would think is on the list. Fuzzy front end. Sometimes you spend too much time creating a perfect plan and you don't get into the deep water soon enough. So fuzzy front end is when you define and plan and you try to perfect your plan without testing some of the things that you're putting on your plan. Code like hell programming, silver bullet syndrome. Sometimes your managers, they hear about the technology at a conference and they come back and they ask you to give them a tool with that technology and think they're going to solve all the problems with that single technology. So this is some of the thinking that may come from the upper level management. You are responsible for protecting your team against that. And most of these, so as I told you, more than 40% are related to people, more than 40% related to processes, single digit on product and technology in terms of percentage. And as you see, the top are all process related. None of them is technology. So if you think you have the skills and it's going to save you with your project, it will not. One of the items on the list is adding people to a late project. That's a classic mistake. Why is that a classic mistake? Adding people to a late project.
Because they would not have the knowledge of the project from first. I mean, it's like, yeah.
Exactly. So you have to spend time training them. There will be communication challenges. You're adding people to your project. It means that there are so many other pieces in terms of communication, and bring them up to the speed and keep them in coordination with other team members. So this is one of the other items related to people on the list. And I want you to look at these charts from the Mythical Man Month book. And I want you to take a look at them for a minute. So there, one dimension is man, the number of people, and the other dimension is time. So let me read the first chart for you. The top left is saying that if a project consists of perfect partitionable tasks, yeah, it means that you can divide the big project to smaller pieces, and those pieces are not very interrelated. That's a key. So perfect partitionable task. You add people, the time goes down. Do you see that? So the curve goes down. You add more people, the time goes down, and it continues to go down. But then you have three other charts here I want you to read and make sense of. So go ahead and spend a minute, and I'm going to ask you by your names to share your perspective on these charts. If you haven't talked yet, you know that you're going to be asked to talk soon. Go ahead, Churchill. Explain the top right. Unpartitionable task. You add people, what happens?
Yeah, hi.
Hello.
Yeah, with the right one, when you add more people,
what happens? Does it make a difference?
No difference. It goes, yeah, straight, the straight line is there. No.
Doesn't make any difference. This is a task, this is a project that's not decomposable. By the way, some of you with artificial intelligence or computer science background, you've heard about decomposability by Herbert Simon. That's a big idea in artificial intelligence too. So if it's not decomposable, you add people, nothing happens, no gain. Go ahead, let's see who hasn't talked yet. Aisha has talked, Manasa has talked, Lance, Matthew, Eric, Shivani, Pranavi, everybody has talked, yes? I think everybody has talked. So this is round 2. Let's go to the bottom of the list I see in front of me. So that's Jonathan. What is the bottom left saying?
It's saying that at a certain point, it will level off. So no matter how many more people you give it, it's not going to reduce the time.
Exactly. That's most of our projects, because you can decompose the project, but people still have to talk to each other, have to coordinate. There is a gain. If you add people, the time goes down. After some point, there is no gain. And that's why you see that adding people to a late project is considered a classic mistake, because in most of our projects, we need to communicate with people who are working on other pieces. How about this one? Let's go, Chingy. Shi, go ahead.
Yeah. I think it's like with more men's, and at first the time will decrease, but when the man is more than some rate, the time will increase some, but it's not up to the original one that no people want.
Exactly. So this is another case of when adding people would be a mistake, because the task is complex, and it requires complex. The pieces are interrelated. Yes, you gain some by dividing and assigning to different people. After some point, it's counterproductive. So it's gonna hurt you adding new people. Good job reading these. The list of classic mistakes I showed you, and these are some of the remedies you see at the top. Agile development communication plan, some of the tools and techniques. I let you read these documents, but some of the tools and techniques listed here are the things that we're going to work on in this class. So this is the top classic mistakes and some of the remedies that may help with them. All right, I'm going to ask you, what is a project? What is an IT project? We talked about failure rates. We talked about success rate. We talked about challenge project. We talked about triple constraint: time, scope, and cost, quality in the middle. We talked about some of the classic mistakes. All of these are related to information systems project. What is a project? Give me your definition. Let me go by my list. It's you, Pranavi. Give me your best definition of a project.
I think a project is something you wish to work on when you have a specific goal.
Exactly.
And you take a step-by-step process to achieve that goal, and you take that as a project.
Exactly. So a project is a temporary effort undertaken to accomplish a unique purpose. So there are IT operations and there are IT projects. Your operations are done at a daily basis. They are happening every day. You're providing services, but a project has a specific beginning and end and a specific outcome or purpose, as Pranavi suggested. Project management is a set of knowledge, skills, tools, and techniques to help us manage project activities to meet the requirements. So a little bit of project management happens in the course as it relates to our analysis and design. So when needed, we talk about user stories and how they fit in the story maps and how that would help you with the planning. So some of the project management pieces will come us here in the systems analysis and design course. And most of the semester, we're going to focus on techniques and tools. So we're going to teach you a technique and we're going to help you practice doing them in class. What goes after that, it's up to you. You're going to spend extra time doing extra activities using the same techniques. That's really great. But we're going to give you the foundations here in this class and hoping that you're going to contribute to the profession, bringing that failure rate a little bit lower. These are the 10 areas defined by Project Management Institute as knowledge areas. I'm going to read them from top left. When you're doing an IT project, you're going to manage stakeholders, There are tools and techniques for that. We are going to talk about them briefly. There is procurement, facilities, infrastructures, people, tools that you need to procure. Risks related to the project, there are techniques for managing them. We're going to talk about that. Communication with different groups of stakeholders, the format, frequency, and structure of those communication. And as you see, cost, time, and scope are here as well. Quality and human resources there, and integration is the part that you put everything together. Don't get overwhelmed or confused. Some of you have seen this before, some of you haven't seen this, but one thing I can assure you is that you're gonna learn here some of the things that you need. So if I ask you a question next time and I feel like some of the concepts are not there yet, we're gonna find activities for you to practice techniques related to the concepts that we introduced. So going back to the core processes of systems development lifecycle. So taking a pause here, we talked about projects. We talked about projects success, failure, and challenge, depending on their size, depending on the approach. We talked about Agile versus waterfall approaches to SDLC. We talked about PLC and SDLC. We talked about project management and project management knowledge areas. And now we are going back to system development lifecycle. So project is a broader concept. So you have money, you have scheduling, you have procurement, and then contracts, facilities, licenses, everything around the information systems production effort. So project is broader, and then you have SDLC that happens inside the project. Let's look at these SDLC phases as a reminder of what you may have seen before, or for some of you, as we have realized, this might be the first time. So the core processes of SDLC, we have identified problem and obtain approval as the first phase. And then in that, you're going to identify the problem you're trying to propose a solution for. You want to quantify project approval factors. There are numbers you have to put together. All these numbers, all these efforts will go into a document. We're going to talk about that document in a few minutes. You're going to talk about risk and feasibility of the project, and then review with your sponsors for approval. So if you haven't seen this, or it's your first time, this is just the beginning, the first step, putting together ideas, proposing a solution, and trying to get money for this solution so you can actually work on it. One document that you create here is a vision document, a very simple document that talks about the problem, your proposed solution, and the benefits of your solution. So you're gonna say that we have a lot of customers, but they're not spending as much money as we want them when they visit our website. So what can we do? Can we have a recommender system added? You know, one of those intelligent recommender systems, they propose items to you. Maybe we can add that. And if we add that, these are the numbers. So every customer is likely to purchase this many more items a year. And this is going to add up to this much more money for the company. So to the bottom line. This is the process. This is the beginning, a very broad, very high level document. You don't have all the ideas and numbers yet, but you want to propose the idea. These ideas, they go to the vision document. And then you're going to put together more details. You're going to do cost benefit analysis. You look at the cost of development of your idea. Is it the purchase? Are you going to purchase a tool for the company and customize it? Are you going to to develop something in-house? Are you going to contract out the system to a third party? So you are going to do those options, what we call alternatives, and you're going to do cost benefit analysis of those alternatives. Look at their development, look at their support costs, and look at their benefits and estimate return on investment, cash flow, and break-even points. So you're going to put together those numbers. So just wondering how many of you have done cash flow analysis, ROI, or break-even point before? In life, in internship, in projects? No? I don't see any hands. So this is part of the planning. You're going to create numbers, crunch numbers, and propose solutions. Then you're going to compare different alternatives and propose one, and then that will be approved. That's when you go to the planning phase, when your proposed solution is approved. In the planning phase, you're going to create the project environment, schedule work, staff your work, and allocate resources to specific tasks. You want to monitor and evaluate, and you want to make sure everything goes as planned. So planning and monitoring. I'm going to stay here first because time is almost up. Second, I want you to look at these core processes and look at this project. This is an iterative project. There are 6 iterations. Do you see that? And the bumps, the curves on the area under the curve shows the amount of time and resources you are spending on any given phase during any given iteration. So let me read the first iteration for you, and then I would expect you to read the rest of it for us. So during the first iteration, look, the first column here. What's happening here? You spend a lot of time on identifying problem and obtaining approval. You spend a lot of time on planning and monitoring efforts. You spend a little bit of time on discovering, a little bit of time on design, a little bit of time on building and testing, and no time on deployment because you don't have anything yet. This is just the first iteration. So go ahead, Aisha, what happens in the second iteration in terms of allocation of your time and resources?
I think not much time is given on the first thing.
A little bit of time on.
A little bit of time, yeah.
Yep.
And in planning and monitoring the project, time is also spent. Time and things are spent, and again, to discover. Yeah.
What's the big chunk of your time spent on?
Yeah, to discover and understand the details.
Exactly.
And to design the system components, little time is spent, and to build, test, and integrate system, little time is spent, and to complete system, no time is spent at all.
This is an example iterative project. It has 6 iterations, and as you described, Aisha, for them, they didn't do any deployment in the first 2 iterations. Go ahead, Shivani, explain this third iteration. You're muted still.
Sorry.
That's okay.
Okay. In third iteration, very less time is spent on identifying the problem and obtaining approvals because that is completed in first and second iteration. Then most of the time is spent on discovering and understanding the details. Sorry, design system components and build, test, and integrating the system components. So most of the time is spent on that, and little bit of time is spent on complete system testing and deploy the solutions.
Perfect. What happens in the fourth iteration, Matthew?
So in the fourth iteration, that's when you completely stop doing identifying the problem. You should be into the part where you're actually implementing the key portions of the project itself. That's when you're doing most of the testing and making sure that the system works. And then you're slowly getting more into the actual completion of the project.
Perfect. So, and this is just an example. If maybe you do it with your team, your bumps will be a little bit higher, lower, and different than this example. But you understand what's going on. More and more time is spent on the later phases of SDLC as you move through your iterations. Class, you did really well with participation. I am grateful for your attention. I'm grateful for the presence, positive presence. Obviously, very grateful for the cameras that are on. It makes class feel really different and much better than the classes with all black boxes. There are a few items for you on ReggieNet to take care of this week. There is introduction video, there is a mini assignment, and there is a syllabus quiz. I want you to work on them during this first week. I set the deadlines. I'm not sure if the ReggieNet says that, but I'm going to change all the deadlines to Sunday at midnight. So if you have any issues with access, just let me know. I'll see you on Wednesday. Be prepared to work on a diagram on GenMy model. I'll have a description. We'll work together, and you're going to be done with your lab exercise during the class time. You're going to submit, and then we'll go to our next activities. So see you on Wednesday. If you have any questions, I'm here. If not, I'll let you enjoy the rest of your evening.
Sure.
Thank you very much.
Thank you.
Thank you very much, Dr.
Thank you very much.
Thank you.
Bye-bye. Thank you.
Bye.
Bye. Bye. So those of you in IT 400, if some of you are here, I need to talk to you. Anybody in 400? No?
Yeah, I am.
I shall just stay a little bit longer.
Okay, sure.
I think also I am.
So I need to ask you. So that means that you're not on 432, so you don't see my ReggieNet for 432? No?
Yeah, we can see. I can see your ReggieNet on for ID 432.
You can or cannot?
No, I cannot see.
Okay, so then I have to work on that. I just needed to ask you for that. I'm gonna add you to my ReggieNet page, but sometimes for some reason the system doesn't let me do that. So I'm gonna send that notification in 10 minutes. And if one of you just gives back a note saying that I have access, then I know it's good. If I don't hear from you, then I know you don't have access, okay? I'll work on it. 10 minutes, okay?
Okay.
Look for that email. Take care, bye.
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 Thank you. Bye.
Thank you, bye. Take care. I'll be in touch. Look for that email.